Okay, we are going to work through a few problems on Kuta software systems of equations word problems for Algebra 1. These will be on the PSAT and the SAT. The story problem versions of these will be. We're going to start with a few easier ones, though. Number 1 says find the value of two numbers if their sum is 12 and their difference is 4. So we know that there are two numbers. We'll call them x and y. We know that if we add them, their sum will be 12. And if we subtract them, their difference will be 4. So we just need to look at this like a systems of equations and decide if we can use substitution or elimination. Either would work on this one, but elimination would be the easiest. So if I add these two equations together, x plus x is going to give me 2x, and a y plus a negative y is going to give me 0. It's going to cancel out. And 12 plus 4 is going to give me 16. So I know that 2 x's are equal to 16. If I divide each side by 2, I know that x is equal to 8. And then remember what our clues were. We know that since x is 8, we know that 8 plus something equals 12. So now we know that y is 4. And we can check it in our second equation. 8 minus what equals 4. And yes, y is 4. So that is it for problem number 1. Problem number 2 is pretty similar. It says the difference between two numbers is 3. So I know that I have two numbers, and then if I subtract them, I'm going to get 3. And it says their sum is 13. So again, if I add my two numbers, which are x and y, I'm going to get 13. Just like the last one, we could do substitution or elimination. But if I add these together, my negative y and my positive y will cancel out. So that's going to be the easiest way. I'm just going to add the two equations together. So x plus x equals 2x. A negative y plus a positive y cancel out to make 0. And then 3 plus 13 equals 16. So again, 2x is 16. So 1x would be 8. And then we plug it back in to see what y is. If I put it here, I'm going to have 8 minus what equals 3. That's going to tell me that y is 5. And then I can check it down here. Is 8 plus 5 13? Yes, so we also got that one right. We're going to skip number 3. That's not the most common type of word problem for systems of equations, but number 4 is very common. The kind of problem where a school is selling some student tickets and some adult tickets, and they tell you how many they sold and what the total price was. So number 4 says the school that Stefan goes to is selling tickets for a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets. So I'm going to say S is the number of senior tickets. And 1 child ticket. So I'm going to say C is the number of child tickets. So 3 senior citizen tickets. I did that wrong. S is going to be how much a senior ticket costs. And C is going to be how much a child ticket costs, because that's what we are finding out. In the very end of the problem, it says find the price of a senior citizen ticket and the price of a child ticket. And then our clues is that 3 senior tickets plus 1 child ticket costs $38. The next sentence says the school took in $52 on the second day by selling 3 senior tickets and 2 child tickets. And it says they made $52 selling that. Find the price of a senior citizen ticket and the price of a child ticket. So we have our two systems of equations. We know that 3 times the cost of a senior citizen ticket plus 1 times the cost of a child ticket costs $38. And 3 times the cost of a senior ticket times 2 times the cost of a child ticket equals 52. So we just need to look at these like a system of equations. So if I add these, nothing cancels out. I'm going to get 6s plus 3c equals 90. So let me see if I subtract them, if we get anywhere. And if I do subtract them, the s's will cancel out. 3s minus 3s is going to be 0s. I'm not going to write that down. 1c minus 2c is going to be negative 1c. And then 38 minus 52, it's going to be negative 14. So I know that I could divide each side of this by negative 1. And I'm going to get c equals 14. So that means a child ticket costs $14. And then I need to plug that back into either equation to find out how much a senior citizen ticket costs. So I'm going to plug it in this one, where 3 seniors plus 1 child, which is $14, equals 38. So I'm going to say 3 senior tickets plus 1 child ticket, which is $14, equals $38. Then I just have to solve this equation. So I'm going to subtract 14 from each side. I'm going to get 3 senior tickets cost $24. And then if I divide each side by 3, I'm going to get 1 senior ticket costs $8. So we know that a child ticket costs 14 and a senior ticket costs 8. Number 5 is a little different, or I would solve it a little differently. It says the sum of the digits of a certain 2-digit number is 7. Reversing its digits increases the number by 9. What is the number? Well, 2-digit number that the numbers add up to 7 could be 7 and 0, or 6 and 1, or 5 and 2, or 4 and 3, or 3 and 4, or 2 and 5, or 6 and 1. It's probably not 0, 7. So these are the different options. My number could be 70, 61, 52, 43, 34, so on. And then it says reversing the digits increases the number by 9. Well, if I increase this, or if I reverse this, it's not going to increase. It's going to become 16. Same with this. 52 is going to become 25. So we know it's not that. It's not that. The second number is going to have to be bigger than the first number. So here we have 34, and if we reverse it, it's going to be 43. That has a difference of 9. We can go ahead and check our others. 25 would reverse and become 52. That's a lot more than 9. Same here. 61 would become 16. That's a lot more than 9. And 7 to 70 is a lot more than 9. So we know just by solving it that way that the 2 digits are 34. The question's actually worded, what is the number? That would be of the original number. So that's going to be 34. We are going to skip down now and do number 10. It says Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Matt sold 3 small boxes of oranges and 14 large boxes of oranges for a total of $203. Ming sold 11 small and 11 large for a total of $220. Find the cost of 1 small box of oranges and 1 large box of oranges. So it's telling us we're finding the cost. So S is going to be the cost of a small box and L is going to be the cost of a large box. The first clue that it gives me is that Matt sold 3 small, so he made 3 times the cost of a small box of oranges, and 14 large, so 14 times the cost of a large box of oranges, and that totaled $203. Ming sold 11 small and 11 large, and that totaled $220. So we're going to solve it just like we did the others. It's a system of equations. I just need to look and see, can I add these together and get anything to cancel out? Or can I subtract anything and get anything to cancel out? And no, I can't. So this one's harder. I'm going to have to make one of these numbers the same as another number. The first thing that comes to mind for me is I'm going to multiply this one times 11 to make this 33. And then the bottom equation, I'm going to multiply everything by 3 to make this 33. And then I can subtract. This would be on the calculator section of the SAT, so you can save time by using your calculator to multiply some of these numbers. So 11 times 3 is going to be 33s. And then we need to know 11 times 14. That's 154 L. And then we need to know 11 times 203. And that is $2,233. And then we're going to do the same with our bottom equation. We're going to say 3 times 11, that's 33s. And 3 times 11, again, is going to be 33L. And then 3 times 220, that's going to be 660. And then I can tell that if I subtract these two equations, 33s minus 33s, those will cancel out. So that's what we're going to do. 33s minus 33s is nothing, cancels out. 154 minus 33 is 121. So 121 large boxes costs whatever 2,233 minus 660 is, which is 1,573. So I know that 121 large boxes cost $1,573. I'm solving still for L. I want to know the price of a large box. So I'm going to divide each side by 121. And that gives me $13. One large box of oranges costs $13. And then I'm going to plug that back in to either equation to solve for the cost of a small box. So I'm probably going to plug it into this one, into the original equation. So I know 3s plus 14 times 13, the cost of L. We're going to substitute 13 in for L. So 3s plus 14 times 13 equals 230. And then I'm going to figure out what 14 times 13 is, which is 182. And then if I'm still solving for S, I want to subtract this 182 from both sides. So when I do that, I'm going to get 3S equals 203 minus 182 is 21. So the cost of 3 small boxes is $21. If I divide each side by 3, I'm going to find out that a small box costs $7. Small boxes are 7, large boxes are 13.